Thank you everyone for joining us for today's webinar on Qt OPC UA, an overview. My name is Erica and I'm here to just help you out with any questions that you might have about the Zoom console here. So first of all, the first thing that I'd like to go over just to do some little bit of housekeeping here is if you have any questions during the presentation, can you please put that into the Q&A box because that's what we'll be watching instead of the chat box. Also, I am recording this and we will be making this available within the next couple of business days along with, the recording along with the slides. So with that, I'd like to hand it over to our first presenter for today, Michele Rossi, who is the product manager for industrial automation.
So, please, Frank. Hello, everybody. My name is Michele Rossi. I'm currently product manager for Qt for Automation. I'm based in Berlin, and today we are going to see an overview of Qt OPC UA. But before to start talking about OPC UA topic, I would like to go through a quick introduction of the Qt company today. Please, Frank. So the Qt company today, it's a worldwide company, has a global coverage with our offices in Tokyo, Europe, Berlin, Oslo, and also in US, Boston and Santa Clara. We are 300 people worldwide around, and we are covering many industry. And today the main focus will be, of course, OPC UA that is mainly used in industrial automation. But before to start talking about OPC UA, please, Frank. I would like to give you just a quick overview about what are we doing for automation today. So for us, automation is a focus of two segments. One is industrial and one is infrastructure automation. And we would like to see Qt as a solution of the edge of the internet. So in this case, the feature we are mainly focusing are the one listed in the left part of the presentation. The main two items are remote UI and connectivity aspect that you can see also in the table from the module of the Qt offering today. So today in Qt for Automation add-on, we include the Qt MQTT, Qt KNX, and Qt OPC UA as a tech preview. And now we are going to see, please, Frank, how to get Qt for Automation. If you are interested in understanding and play a little bit of our Qt OPC UA implementation, please feel free to download the Qt for Automation add-on that is available on our website. You just have to type Qt for Automation in Google and everything will comes up. Okay, thank you very much. I'm going to leave the word to Frank.
So, welcome everybody. My name is Frank Meerkötter, and I will today give a quick overview about Qt OPC UA. I will start with a short introduction of basysKom. Why are we doing Qt OPC UA? Introducing also the protocol, Qt OPC UA itself, and after that I will do a live demonstration where I'm extending an existing industrial application with a Qt Quick HMI, which is connected to some OPC variables via Qt MQTT, Qt OPC UA, of course, before having a look at future directions of Qt OPC UA. So let's get started. This one we had. So about basysKom, why have we initiated Qt OPC UA? basysKom is a long-time Qt service partner. We are focused on industrial applications of all kinds, embedded systems. Our typical customers are from the machine manufacturing world, are automation customers, and also producers of measurement devices. We are located in southern Germany, in Darmstadt, as well in Nuremberg. And we are in that area, we are offering consulting, training, and also development services. Quick introduction of myself. I'm the development lead for basysKom, which is a technical role. I'm overseeing the consulting and development projects within basysKom, and this is what brings me here today. I'm also the maintainer of Qt OPC UA. If you have any questions towards presentation or towards Qt OPC UA, feel free to drop me an email just asking it. So, with that aside, OPC UA in a hurry. OPC UA is a big standard, so I have 4 slides, I think, about OPC UA itself, so this needs to be in a hurry. I just want to give some orientation for the following slides so everybody's on the same page. So OPC UA well, OPC is nothing new. OPC UA is a successor of the of OPC, which has been established in the 90s already. It's now called OPC Classic, just like Bluetooth is now Bluetooth Classic. It's a machine-to-machine communication protocol as well as a communication architecture. So it wants to be more than just a protocol. It also gives some hints and help how to do things in a proper way, how to model data. It has its core application in industrial automation, for example, in manufacturing and in process control, but it's also used in areas bordering these core applications. The main goal of OPC UA is interoperability, so to make it easier to integrate machine parts from different manufacturers, different producers into one application. It is an open standard, which meanwhile is also freely available from the website of the OPC Foundation, which is also developing this standard. It has been also standardized internationally. The standard is it's split up into a core standard, which is 14 parts already with way north of 500 pages, as well as a set of so-called companion standards. The core standard basically specifies the protocol encoding, stuff like this, as well as some built-in information models, and the companion standards are specifying information models and definitions for certain vertical industries or problem areas. There are 15 which have already been ratified, and there are more coming, all with the idea of enabling interoperability. So this is what OPC UA is on a very high level. Who is doing it? Which problem does it want to solve? Next up, if you're leaving aside part 14 of the standard, which is new, it's a client and server system. The servers are providing a fixed set of services. There can't be any more, and the clients consume these services. And the main objectives of these services is to allow clients to manipulate and to access data on the server and to discover the data on the server. It's not a strict distinction between clients and servers. There are certain scenarios where devices can be servers as well as clients at the same time. One example could be a scenario where PLCs are coupled together via OPC UA or aggregating servers, giving access to several PLCs. These are all scenarios where devices are clients as well as servers. So it's client and server based, and data modeling. This is also an important part of OPC UA, which I would like to highlight. So servers organize their data in a so-called address space. This one is split into namespaces. So namespaces are just a way so that different organizations don't run into each other with their data modeling. These address space contains a fully meshed graph of nodes and references. Nodes are data objects on the server. They contain attributes. These attributes are stuff like a description, a human-readable description, a display name, something I can display on my HMI, but of course a value. A value could be, for example, a pressure value or something like this. So these nodes are now, they need to be put into relation to each other, and this is where references come into play. There's a huge number of references in the standard, which have a very defined semantics, stuff like has child, has component, organizes, is organized by, is child of, and they are used to put nodes into relation to each other. And this is part of the idea of having data as well as metadata in this address space to make it self-describing and therefore to enable to write more or less generic software which is able to deal with a controller on a much higher abstraction level. There's a standardized set of modeling rules which describe how this happens. And also there are standardized information models describing how this happens. A few of these models are part of the core specification, and the other ones are industry-specific, part of the companion standards. So we have a client and a server and a rich set of modeling facilities enabling us to organize our data. If I say, well, there's a fixed set of services, what I would like to give a few examples. There's, for example, the session service set, which allows me to connect to a server and to maintain a session on the server. There's the browse service set, which allows me to discover attributes and references on the server to find stuff there. There's the attribute service set, which is allowing me to really access attributes on the server. Simple example, to read that pressure value. There are monitored items, which are basically telling the server to monitor a certain attribute for changes. And in combination with that, there are also subscriptions, which are used to deliver these changes on monitored items to clients. I've picked these. There are more services. I picked these because this is all stuff we will later need when looking at Qt OPC UA. And with this, I'm already closing down with my OPC UA in a hurry. That's basically a first orientation, which is very generic. And we will now have a look at Qt OPC UA, which is a new module that has been initiated and also upstreamed to the Qt project by basysKom. We started with this already in 2015, which is a long time ago in a way. What happened since then? In 2016, we basically did a lot of research and also talked to a lot of users about use cases, about how to structure an API. Should it be do we need a QML API? Do we need a C++ API? And based on that, we got together with the guys from the Qt company and fleshed out a new concept for an API, which we then also implemented. And all of this is now come full circle with a technology preview in Qt 5.11, which has been released end of May, so which is now available to everybody to use. basysKom is sponsoring one full-time employee as well as a module maintainer for this module, and we are developing it together with the Qt company, which is also having one full-time developer on it. What is Qt OPC UA? It's an API in the core. It's a wrapper for an existing set of existing stacks, so it's not a full re-implementation of an OPC UA stack. There are two plugins for existing stacks available. One is for the Open62541 stack, which is a free re-implementation of the protocol. That's an open source project, very active, and this is also something where basysKom is also working upstream. And there is the unified automation backend, which has been implemented by the Qt company, which is covering the commercial side. Unified automation is a well-established OPC UA stack, and we're offering also backend for this stack. So this is very high level. What is Qt OPC UA? the mission statement. What are the goals of Qt OPC UA? OPC UA is a large subject area, and when we started, we felt that we need to define a focus of the development effort. What should we do first? What is a lower priority? And we picked out that we want to have a client API, so we can create. You can create a client application with Qt OPC UA. Of course, it needs to be well integrated into Qt, so it needs to be asynchronous, not blocking the event loop. It should use Qt types where possible, so it nicely blends in. And of course, it should have, like it's the fashion with Qt, it should have an easy-to-use API. We also defined a few non-goals, at least for the first iterations. So we don't do a server API at the moment, and we also put aside high-performance data acquisition applications. This doesn't mean that Qt OPC UA is slow, but it's not the main focus to cover these applications. So to that end, we created an API, and we had the idea to have something simple and easy to use. So we boiled it down to two basic API elements, which I now introduce because I will use them in my live coding session also. The Qt OPC UA client, which is basically an abstraction for the session service, which does connection management and also allows to create node objects. Node objects are of type Qt OPC UA node, which is an abstraction for nodes on the server, and within these nodes for attributes, and in its core they allow to the reading and writing of attributes, so I can find out about the value, I can change the value on the server. And the Qt OPC UA node also allows to set up subscriptions and monitored items. I've placed the link to the documentation, which provides a detailed overview. And well, I come back to this in a second. Before I go into the live demo, I would like to give a quick overview about the features which are available with 5.11 with this tag preview. So we have a fully asynchronous API. This should nicely integrate into an event-driven HMI. We have session and connection management. We can read and write node attributes on the server, also in an asynchronous way. We have a way to set up the monitoring of values, of value changes. We can call methods on the server, so the RPC service, and we can browse the server address space, searching for certain nodes. These are the features we have, and before I go into the live demo, I would like to tell you how to get access to Qt OPC UA. Unlike the rest of Qt for Automation, this code is triple licensed, so it's commercially available. It's GPL v2 and LGPL v3. So either you get it directly from the installer if you're a license holder of Qt for Automation, or if you aren't, you need to compile it yourself from the source. If you're a GPL or LGPL licensee, the source code you find at code.qt.io. And at the basysKom blog, you also find, for a number of platforms and operating systems, you find detailed instructions how to compile it yourself from source. And with that aside, I would like to get into a live demo, demonstrating how to use these elements I just described. The live demo is, for this live demo, I would like to extend this showcase we have here with a new Qt Quick-based HMI. What you're seeing here is a showcase basysKom is using for trade fairs, but is also a testing ground for us to try out new protocols, develop new HMIs for it, to try out things. And what you're basically seeing here is on the left side, there's a production line. Next to it, there's a backhoff PLC. And the backhoff PLC contains an OPC UA server. Next to it is a device called an IoT and HMI gateway, which is developed by us. It contains a Qt OPC UA-based client talking to the PLC. And it also contains another OPC UA server. So the idea is that's a so-called aggregating OPC UA server, even though we are aggregating over one, but it's basically also doing access control and things like this. We have implemented this with Open62541. And this is basically offering services for all the HMIs you see below. And in the next 20 minutes, I would like to add a new HMI to this. Here on the next slide, I have a diagram basically outlining this a bit, and only the parts that are marked with the red arrows are basically relevant. The machine is not pictured, but you have the, that's German SPS or PLC. We are using Qt OPC UA to talk to this controller, and we have a QML HMI, which uses Qt OPC UA, which we use to talk to the HMI gateway. Oops, that was too fast. So now on to the demo. Here in the Qt Creator, I've selective. I didn't bring the Beckhoff PLC, but instead I've created a simulator, which I need to start. This HMI backend is a part of the software running in the IoT gateway, which connects to this. And we have an existing QML client, which is using Qt OPC UA to talk to this setup. So basically, quick rundown, it allows to start, stop the machine. It would also allow to confirm errors. You have a bit of logging functionality here. You have a dashboard outlining metrics, and you have the ability to change parameters of that machinery. And for that, I would like to add another HMI in the next 20 minutes, which is basically a dashboard. A simple one. Let's imagine this is a dashboard we want to place somewhere on the production floor, and it should represent the state of the machine. So it should reflect the state here. So how do we do this? Let's get started by picking out the right, by validating that we have the right variable. I'm using the Unified Automation UI expert for this. So we are already connected. So I can just, here we have this is the OPC UA server contained in the HMI backend. And here in the objects folder, I have a variable I'm interested in. So I've put it here into the document, which behind the scene is creating a it's creating a monitored item, a subscription. And I will now use this to validate that we have actually the right variable. Let's stop it. And you see the variable changes. Put it in manual mode. Okay, we have the right variable. So what's the name of this variable? It's namespace 2.machine status. I come back to this later. Let's put this aside for now. And let's have a look here at the dashboard I've prepared. I won't go into the details of the Qt Quick application, but I'll really start by adding the Qt OPC UA functionality. We need to add the OPC UA module to the Qt variable, so the libraries and includes are there. And well, in the end, we want to do some property bindings for the Qt Quick HMI, so we need to create something QObject-based, so we can add properties here. So I will add a C++ clause. Let's call it machine status. That was too fast. That's QObject derived. Okay. Okay. And of course, we need to instantiate this. So let's add the include machine status and put an object on the stack, machine status I come to this, back to this later. So what do we want to do? We need an Qt OPC UA client. Let's add a helper for the memory management, Qt scoped pointer. And let's create a few member variables, Qt scoped pointer with a Qt OPC UA. We need to add the include, of course. There's a nice convenience include, Qt OPC UA, which contains a lot of the Qt OPC UA headers. So we can, this should be a private Qt OPC UA client. Let's call it mClient. And while we're here, to save some time, I'm also creating Qt scope pointer for a Qt OPC UA node, which represents the status variable on the server. Let's call it status node. And one thing I didn't explain yet is, as we have all these different backends, we need a way to configure Qt OPC UA with a certain backend. This is done with a Qt OPC UA provider. Let's do some QDebug based development. QDebug. So we've created this provider. We only need it to instantiate a certain backend. So let's ask it, which backends do we have? QDebug. Provider.available backends. Let's run this. And it's compiling. Okay, so it's here in the debug console, you see it found two plugins, Open62541 and FreeOPC UA. FreeOPC UA I didn't mention so far because it's deprecated. It will go away with Qt 5.11. So at least it found a few plugins. Let's instantiate one. So client.reset provider.create client. You need to provide a string, Open62541. And let's do a little bit more QDebug based debugging. Client.data. Let's see if this works. At least it could instantiate an object, so we can do the next step. Okay, as I mentioned, it's an asynchronous API. So let's have a look at the client header. It has a connect to endpoint method, which sounds promising, and it has a few interesting signals, among them the client state, which contains enum, connecting, connected, disconnected. This sounds promising. Let's work with this. We need a slot for that. State changed. Let's use this. Let's create a slot for this. Could be also a private one. On state changed. And let's implement it. So we have our slot. Let's put a QDebug there to validate it. Let's print out the state. And of course, we need to connect it. Let's do a connect. So we want to connect the client, which is a Qt OPC UA client on state changed signal with this object, which is of type machine status on the slot is on state changed. So far, so good. And now we need to call the asynchronous method mClient dot connect connect to endpoint, which takes a Qt URL. This is custom URL scheme opc.tcp. It's running on my local host and on port 4040. So let's see what this does. Well, it's compiling. Let's see the application output. And you see here, there are several state changes, connecting, connected. So we are now at this point connected to our aggregating OPC UA server. And next on, we can, now that we are connected, let's make sure that this is the case. And client, no, this is not what I want to do. State is equal to Qt OPC UA client state connected. And for the case that we are connected, I would like to ask the client for node object. Let's do this. Client node. We use the UA expert to find out about the node ID. So this is not really best practice. You shouldn't normally assume that there are hard-coded namespaces and hard-coded node IDs. So there are more elegant ways to do this, but I only have 20 minutes. So we need to take some shortcuts. The namespace is 2, and it's a string-based identifier, which is named .machine status. And let's put this into the member variable I've prepared earlier. Status node dot reset, as it's a smart pointer. Let's put it there. Let's do some QDebug based debugging, validate that we actually have something. Status node dot data. Let's run this. Let's and a few of these. So it's compiling, and we got a node object from the server. This is something we can work with. So we now want to monitor this variable for changes. So each time the state of the machine changes, I would like to, here, if I do this, I would like to get a status update for this attribute. So we need to connect we need another slot because it's a signal we want to subscribe to. So what kind of signal is this? Let's have a look at the header of the OPC UA node object. There are a number of interesting signals, and the one that sounds promising is attribute updated. So let's define this slot. So it's called on attribute updated. Let's implement it. Some more QDebug based debugging. Let's just output the value for this case. But so far we are missing something. We still need to connect the slot, which is again using the connect status node data. The object type is Qt OPC UA node, and the signal is called attribute updated. And we want to connect it to this object, and this is of type machine status on attribute updated. So we now have wired up this slot. And now that we have this, we need to enable monitoring. So we need to instruct the server to tell us if the value changes. So we do this like this: status node, enable monitoring. A node has a lot of different attributes. It has an ID, it has a browse name, a display name, a description, it has permissions, and it has the value itself. So we need to tell this Qt OPC UA node, how it's called, node. I'm lost. Here we go. It's a node attribute, and we are interested in having the actual value. We need to configure the how the monitored item and the subscriptions are set up. This is done using a Qt OPC UA monitoring parameter object. UA monitoring parameters, and we just use one of the convenience constructors telling it, well, create a monitored item which is sampled every 100 milliseconds. For the rest, just use some defaults and be done with that. So let's try this out. So this is compiling. And we see that we get an initial update for the value. Let's change it. This we don't need so yet. So let's change the state of the controller. And you see that in our newly developed program, we get status updates reflecting the machine state. So this is all good. So we now have the data we need. The only thing left now is to wire it up to the Qt Quick UI, to the traffic light. To make this happen, we need to create a property, so we can create a value binding on the QML side. So let's introduce a member variable. I'm again taking some shortcuts, and an enum would be nice here, but for now I'm taking an int status. Let's initialize it on the spot. We introduce a Q prop. That was too fast. A Q property. It's of type int. Status is a name. It's a read-only property. And we need a status change, so the value, the property binding works. So let's add a signal, status changed. So now that we have this, we can go into the slot on state, on attribute changed. And now we can check each time that the status isn't equal to, I need to unpack secure variant first. Int temp equals to value dot to int. And each time it's different, we store it in the member variable, status is temp, and emit a value status changed signal. And this is more or less it on the backend side. And we now one thing I forgot, we still need to add a get method, of course. Int status, just do it inline here in the header, and status. But now we are down on the backend side, and let's switch over to, let's wire it all up. So I will use a context property. So let's engine.root objects dot set context. No, this was wrong. Root context set context property. So we call it machine status, and we connect it to this Q object. So that's it. Now we can go into the QML side. And here we have this traffic light component in QML. We would now like to use it. So we say machine status equals 0. So red should be active. So let's do it like this and this. And let's see what we got here. So you notice that the green light is on. So we have something happening here. Let's validate this in combination with the existing Qt Quick HMI. So let's put it into automatic mode, and you'll see the traffic light changes. So within 20 minutes, we added a new dashboard, Qt Quick based, Qt OPC UA based, to an existing industrial application. It's a simple application, of course, but it basically shows all the main elements you can use in Qt OPC UA. And I hope I could give you an impression what can be done at the moment and how convenient the API is. So this concludes the live demonstration and brings me back to further directions. Qt OPC UA is currently a tech preview, so we have not fully committed yet to keep this API stable. Qt is very much committed on keeping APIs stable within major releases. So this is one major point for Qt 5.11. So, but this needs user feedback. So I would encourage you all to give feedback either via bugreports.qt.io. There's a special component, OPC UA. You can also drop by on IRC. There's a Qt OPC UA IRC channel on Freenode. Feel free. The developers are there, or you can just drop me an email if you have questions or feedback on your experience using our API. Apart from stabilizing the API, there are a number of upcoming features for 5.12. Amongst them is event support, so you can consume events that are sent by your server. We are also working on endpoint discovery and transport security. With 5.11, you don't get transport security at the moment. We are adding node management, so you can at runtime add nodes and references or remove them. We are working on a generalized browse support, and amongst others, amongst other features, the Qt company is also working on a QML API, so you can declaratively describe a namespace and have all the objects instantiated you need inside your clients. And with that, I conclude this presentation, and I'm available for questions.
So, Frank, can you hear me?
Yes, I can hear.
So I would like just to, put on the table what kind of application have we done already with the Qt OPC UA module.
Well, as I said on the features on the mission statement slides, so the main focus currently is applications and industrial settings. So that might be a visualization, an HMI, or full application. This is basically the main goal. You saw some examples here in the presentation with our industrial HMI showcase. Apart from that, we also used Qt OPC UA to create in gateway scenarios where we're basically consuming data via Qt OPC UA and sending it elsewhere. For example, using MQTT to send it to an IoT hub hosted in the Azure cloud. This is a scenario we've implemented with Qt OPC UA. We've also created logging applications, basically, which were logging data which don't have an HMI attached but are running in the background on a server. These are examples for applications we've done. More questions?
So this is Eric again. Just a reminder, if you do have questions, please put them into the Q&A. And I think, Michaela, you have a couple, or did you have one other one that you had there lined up?
Yeah, so I'm seeing now one question. So is it also possible to use the API to act as a client node providing info to other aggregators?
I'm not sure if I got the question. Is it also possible to use the API to act as a client node? This is basically the question if it's possible to do a server with this. Is this correct? You can also give me feedback in the chat box, or if I haven't answered your question. So currently, as a client node providing info to other aggregators. So this, well, I guess this would mean to do a server. Is this correct?
Or the MQTT connectors, as you were mentioning before, probably.
Yeah. So if you're going with other protocols, is of course the world is open. There's everything you need. If you well, yes, thank you for clarifying. No, this is currently not possible. So we are focused on the client side. So if you want to provide an OPC UA server, you would need to use another SDK at the moment. We have, for example, done this. Was something that was part of the industrial HMI showcase I showed. So basically, the aggregating OPC UA server, which is the front end for all the Qt clients. This is done with the Open62541 SDK. In the past, we've also implemented functionality like this with the Softing SDK. This is something we are actually being asked about, but it's not. At least there are no immediate plans to do a server-side SDK. Currently, we plan to finish up on the to get a more complete offering for OPC UA clients.
Yeah. But actually, these are all good feedback. So thanks.
There's another question. Is there a common file like XML as communication specification, which I'm not quite sure if I understood the question correctly. OPC UA is heavily relying on XML, to be honest. The core specification makes use of a lot of XML. There are official XML files published by the OPC UA Foundation, which can be used to generate protocol primitives as well as the contents of an OPC UA server address space. This is also something that is used by the companion standards. Qt OPC UA doesn't contain or doesn't directly make use of this XML information, because we are at the moment purely an API sitting on top of the of an existing stack. So if we go one level down, if you are looking at the Open62541 stack, they have a Python based compiler to generate all kinds of protocol elements, and yeah, but this is not something that is part of Qt OPC UA. And also at the moment, not something we need. Please let me know if I'm not thinking about the right, if you have a use case that would be interesting. So, any more questions?
Maybe Frank, you want to disclose the difference between the two backends? I don't know.
Yeah, I can talk a little bit about backends. And we initially started with the free OPC UA backend, which is also an open source implementation, which has become very quiet in recent years, nearly unmaintained. So we will drop this out of Qt OPC UA in 5.12. There are two active backends. So there's the Open62541, which is covering the open source side, which is a very active development community. I can really encourage you to have a look also there, especially if you need a server. This is also an open source community where basysKom is doing upstream work. And there's also the unified automation backend done by the Qt company. If there are requirements to do additional backends, for example, if you would need don't know, softing backend for some reason, this can also be done. Please come forward with this requirement. There's another question. Is it possible to design the server side with a Qt OPC UA module? I think at least in the variant we've answered this question. At the moment, it is a client-side module, so you can't do a server side. You can't do the server side with Qt OPC UA.
With the actual 5.11 release.
With the 5.11, so if there's a lot of interest in a server side, also doing the server side, let's talk. We have some. We need a server also for the continuous integration. So we've created a bit of abstractions for the Open62541 SDK. This could be a seed for a server-side SDK, but so far it's not on the table.
Okay, so that looks like all the questions. I'm just gonna, if you guys don't mind, wrap it up a little bit here. If there's another question that comes through, we can definitely answer that. But I'd like to thank both Michele and Frank. Frank, again, thank you very much for pulling that all together and doing the demo. We will have this recording available. And I believe if you want to go back 1 second here, Frank, you have your contact information if anyone has any requests or feedback on there, if people want to take that down.
Yeah, feel free to drop me an email if you have any questions about functionality, how to get started, use cases you can cover this with this. Just drop me an email.
Okay, great. I mean, otherwise, if the other place you can reach out to is if your Qt representative, and we'd be happy to get you in touch with Frank and get your questions answered about that. Again, thank you, everyone. We will be following up shortly, and we look forward to having you at other presentations like this.
Thank you very much.
Thank you very much.